Jeffrey Alsme, and this is my design of an ice melt dispenser. Alright, so the purpose of this design was to make life essentially easier for me, being that I live by myself and I work a lot. So as a full-time student and having a lot of jobs, there are some duties that I'm not able to attend to while I'm not home. So the original components of this design were a retractable zip line, a remote control operated motor, cast iron electric salt dispenser, and a proc dispenser. Now, the way this originally design was going to operate was that the electric motor will be attached to the zip line, as you can see on the drawing, and on either end of the pole, we're going to be push buttons that activate the motor to operate in opposite directions. The proc sensor is going to be located under the salt dispense machine to avoid salt being dispensed on your car or like humans who happen to be walking by. So prior to this design, I decided to kind of like remodel it so that way it operated better. So last semester, this was the original design of keeping push buttons on either side of the pole to make the machine operate back and forth. There were going to be sort of like hands to like reach out, so that way the machine won't fully bump into the pole to activate those buttons. So the new design would be just the electric motor itself. After talking with an electrical buddy of mine, he showed me a way where if I had a DC motor that was battery operated, I could code that motor so that once it reached a certain distance or length, it could operate in the opposite direction, along with sensors that are attached to the either end of the pole. So the way that would operate is as the motor's operating and as it's approaching its destination, that sensor would notify the motor that, all right, you reached a certain distance, now operate in the opposite direction. Like I said, the original design I had was to have a retractable zipline coil. But having a retractable zipline coil, there were like many malfunctions that could have occurred. One main reason that I decided to switch this design is if you have a retractable zipline coil, you risk having that cable cord not evenly being recoiled back into place. So what I decided to do is to have it manually recoil, so that way it is evenly displaced throughout the coil. So that way the lines won't jam up or knot in. The electric motor. The original design was to have everything encased in that closing, but I realized that wouldn't work either. Just everything, just the whole way it was set up, it just wasn't realistic enough for that motor to operate back and forth on that coil. I mean, on that zip line. So I decided to have a trolley. Basically, I got the idea of watching people zip line down, like down lakes and whatnot. And they had this item called the pizzo trolley, which was strong enough to hold up to 24 kilonewtons. And basically, as you can see, the coil will be feeded through this trolley, where it kind of like dangle on the cable cord as it's attached to the two poles. And I'll I'll keep the salt dispenser because there was nothing wrong with it. The only difference would be that the motor and all the components with the spray gears that is driven for this will be visible on top of that salt dispense machine. Uh, Being that it was spur gear driven, some of the calculations I used a 1 horsepower motor that operated on a 1760 RPM, and what I did was reduce that speed to 800 RPM. With that, I was able to select. I had a couple of set of gears that could operate the machine efficiently, but the one that was best fit for this design was a 16 diametral pitch steel of spur gears, starting with a 12 teeth that meshed with a 24 teeth spur gear. And along the route, I compared like the system velocity, which was about 345, rounded 346 feet per minute. But along with the electric motor, I was able to calculate the distance that it would travel. So using this equation, RPM times diameter times pi divided by 60, with the system operating at 800 RPM and creating the trolley wheels that was located where the cable cord would be fed through, I would be moving this the system at 26.18 inches per second, which is a little bit over 2 feet. So for your standard driveway, probably get, let's say if it was 50 feet, this machine would operate for about 5